Hey guys, welcome to today's video. Let's get straight into it. Now, actually, I have a question for you. From just looking at it, what is f of x equal to? See, initially, you might, if you are, or if you haven't paying attention, you might think that it looks pretty similar to x squared or the quadratic function. And you'd be right. But what changes were really done to this function to do that? I mean, we see it has the points 2, 4, 2, -4, and -2, -4. And we also see that, oh, it is missing some points. But we also have, although not clearly seen, -1, -1, -1, and 1, -1. And if these points look familiar, they should be. But the only difference is that the outputs have a negative sign, meaning that they're all flipped. And this change of an original function, being the quadratic function, is what we call a transformation. And there are actually a crap ton of transformations. And instead of memorizing simply, I guess, what transformations there are, it's best we recognize them. When we see something like that, where, I guess, the y's are negative, right? We see like the y outputs are negative. When shown explicitly, it ends up coming to -x. So when we see a negative outside of the x, we can often assume that the transformation itself is a flip, or let's say reflection, around the x-axis. But what if this negative sign was inside the function? Let's use -x cubed as an example, another of the 10 functions that I showed you all in the first video. And then here, what ends up happening is, or actually, let's do something else. Give me 1 second, guys. Let's have something like, oh wait, what? That was so cool. How did that happen? Yeah, let's use the cubic function. Let's use, why does it just not want to draw there? Y equals -x cubed. And what's happening here is that we're no longer negating the y, but we're negating the x. And if the x value itself is being negated, we can say that there's a reflection around the y-axis. So really the opposite axis. If there's a negative on the y, you end up getting a reflection around the x. And once the x is negated, you get a reflection around the y. But that's really not where transformations stop. We can have something like, let's say y equals 2x squared. What do you think happens to this function? I like if you guys can right now, pull out your calculator or Desmos, which is a online graphic calculator that I very much recommend. And you'd see that, let's say this is how the graph of x squared looks like. The graph actually is a lot thinner and taller. And this change is known as a horizontal shrink. And although you might be thinking, why when multiplying a function by a value greater than 2, why is that a shrink out of everything? And I think if you're confused, we're multiplying 2 x squared 2x. We're squaring 2x, and that multiplying by the x is what really makes it horizontal. And the reason it shrinks is when we're adding a coefficient greater than 1, we're speeding the graph up. What would be, let's say y equals x, when it's made 2x, we're really speeding the graph up. We're making whatever change that wasn't to happen 2 times earlier. And that speeding up really makes the graph take up less space and kind of shrinks it. That is how I like to think about it. If that is confusing, I'm so sorry. And now, that's why when we have something like y equals x over 2 squared, we'd see the opposite, where the graph is being divided by 2. So it's 2 times slower. And since it is 2 times slower, we end up getting something like this, where the graph is a lot wider. And that equals y equals what am I saying y equals? I'm saying this would be a horizontal stretch. And during horizontal stretches, key y values don't change. So here the y-intercept will say 0, 0. Wait. And really, y values are not what are changing during horizontal stretches. And now let's look at something like 2y equals x squared. Sorry for that intermission, guys. I got an important text. And then here, if we were to make the function explicit, by the way, if I have not mentioned this in the past, explicit is simply just y equals, and then you'll have whatever here. And then implicit is when we might have y and other stuff on one side. So like 2y over 3 all cubed equals like x. This is implicit since you know y isn't alone. But let's continue. If we have something like 2y equals x squared, when we make it explicit, you can follow along. You'll get y equals, pause, and now unpause, x squared over 2. And this actually is what we call a vertical shrink. I mean, sorry, a vertical stretch. Am I geeked? Sorry. Yeah, vertical stretch. And that vertical stretch ends up making the graph, as mentioned earlier, 2 times wider. However, the y values are affected when the entire x is being divided. If the division is with the x, then it's horizontal, and when it's without, it's a vertical stretch. Then we have a vertical shrink, which is when, let's say, we have y over 2 equals x squared. When making explicit, we get y equals 2 times x squared. And this, once again, speeds the graph up. However, the y values are being affected here, and whatever roots would have been here remain the same. And that's how you know it's a vertical shrink. Other, I think, easier transformations to remember are, I guess, horizontal shifts. Horizontal, and that really happens when we have something like x plus 3 squared or x minus 3 squared. I'd be surprised if you're not already familiar with this from algebra 2, but there's no shame in not knowing. And here we'd have, sorry if I was corny, I'm sorry guys. When we solve for x, we actually get t off, you get x equals -3. So when you see a plus next to an x, that's usually a leftwards, and here we see a shift by 3. So then we end up getting a horizontal shift by 3, where all x values are shifted by 3. And here the negative 3, when we solve, we get x equals 3. So everything is actually being shifted rightward. So this would be a leftward and rightward. But what if we had something that looks like this, for example? Oh, this? X squared plus 3. Hopefully, if you're familiar, there's x squared. If you were able to remember some stuff from earlier math, or kind of realize a pattern, really what's happening is that we originally had y minus 3 and added 3 on both sides. And this means the y is going to be affected by this plus 3. So the graph has everything move up by 3, which is a vertical shift. And that means something like y equals x squared minus 3. I'll draw the original x squared again for you guys. X squared. The transformation here will result in the graph just being taken down 3. And this is also a vertical shift, but it's downward. That's all you need to know for transformations. These can be a handful to know. And then if it helps, I will add a transformation rule and explanation. However, I would not recommend simply just memorizing this and understanding it. May help. If you would like questions, feel free to leave a comment down, text me. This is mostly for Ethan. And I'll send you pre-made questions that I will not be going over on video. That is all. Have a great day.